Many customers would like to use concept collections to present groups of concepts to downstream systems. These collections can be ephemeral or long-lasting, according to what you want. So how do we create these collections? Well, we go to the collection panel within the KMM and click the Create a Collection button. Now, I'm modeling a situation where the Smithsonian has instances of a number of things that are used on space missions, such as Spaceload's a model of a Saturn V rocket. So you can, from the collection pane, you can add members, or you can go to the concept pane and add the concept to a collection, or even you can drag and drop concepts onto a collection, and there you go. Now, if you publish this model to the concept server, you can extract details of that collection just by making the REST call model name, collections, and in this case I've given the ID of the collection, and we return the members of that collection. When a label has been added to a concept, it is often useful to add metadata to it. This facilitates better governance of being able to state its provenance or any other data that will be useful to downstream systems. If we go to our favorite concept, we can click on this new icon that appears by each label and add in any metadata that we would like to. For instance, and there we go, that concept label now has metadata, and we indicate it as metadata by filling in that icon. We can also define metadata that's specifically for labels. For instance, I'm going to say that I want to create a new metadata domain of label, and it's going to be the date of first use. Obviously, that's going to be a date. So I can now go to my concept and to that label, I can now add date of first use, and I'm going to set. So that label now has 2 items of metadata. And again, we can publish that to concept server, and when we request that concept out of concept server, we get back the metadata attached to that label. When using Semaphore as part of an AI-driven workflow, particularly RAG, it is often necessary to determine the most relevant concepts from a user-entered chat query. These queries can be a lot longer than those to which concept mapping in either semantic enhancement server or concept server has been tuned, so using a semantic search method can lead more reliably to contextually relevant concepts, enabling a more accurate answer to the user's original query. To do this, we configure the concept server to talk to an external embedding calculator, which will return a vector from the data about the concept. We send a bit of context for that concept to the embedding calculator, and that returns a embedding vector, which we store to the MarkLogic 12 database. At query time, we calculate an embedding vector from the user's chat query using the same external LLM, and use the MarkLogic nearest neighbor calculation available from MarkLogic 12 to determine the best match concepts within the model. So I can demonstrate this using Postman. So we do a semantic search on, this is against the subject model, which is one of the standard demonstration models we provide. How do I apply for housing allowance? So I'm setting this to the semantic search method of concept server within this model, and I get back housing benefit, housing allocation, housing grants. These are all sensible concepts. The quality of the response obviously depends on the relevance of your LLM to the model. The data that is sent to the embedding model for each concept can be changed using a template. How do we compare those results with just simple says concept mapping? Well, terms in the query that are not related to any concept are confusing the semantic enhancement server a little until we're getting back results that are less relevant. And even the concept server concept mapping algorithm can get confused by the other terms returning various martial arts, in this case before housing benefit and sheltered housing.